Good morning, my dear students. In this video, we are going to study the third chapter of Class 8 Mathematics. The name of the chapter is Rational Numbers. So first of all, we will understand what is a rational number. Rational numbers, any number which can be expressed in the form of P upon Q, where P and Q are integers and Q is not equal to 0, is called a rational number or simply rational. For example, 5 upon 7, minus 7 upon 11. So for a rational number, it is very much important that the denominator should not be equal to 0. The numerator can be 0, but the denominator should not be equal to 0. All fractions are rational numbers. All natural numbers are rational numbers, as 2 can be written as 2 upon 1 or 7 can be written as 7 upon 1 and so on. 0 is also a rational number, as we can write down 0 as 0 upon 1. All whole numbers are rational numbers. All integers and all terminating as well as recurring decimals are also rational. Irrational numbers. Numbers such as root 2, root 3, root 5, root 7, etc. are called irrational numbers. Equivalent rational numbers. If the numerator and denominator are multiplied or divided by the same non-zero number, we get an equivalent rational number. For example, as I have given here, 1 by 2 is equal to 3 by 6 is equal to 5 upon 10. So let us understand 1 by 2. In this rational number, I have multiplied 3 in the numerator and 3 in the denominator. So we are getting 3 upon 6. If to the same rational number 1 upon 2, if I'll multiply 5 to the numerator and 5 to the denominator, we will get 5 upon 10. So 1 by 2, 3 by 6 and 5 by 10 are called equivalent rational numbers. Operation on rational numbers. So first of all, we are going to understand the addition of rational numbers. Case 1. When the given rational numbers have the same denominator, we can proceed as following. As I have given here, a by b plus c by b is equal to a plus c upon b. So 1 by 2 plus 3 by 2 can be added up like this, 1 plus 3 upon 2, that is 4 upon 2. Case 2. When the denominator of the given rational numbers are different, then what we have to do? First of all, find the LCM of the denominator of the given rational numbers. Then in step 2, find the equivalent rational numbers of the given rational numbers with LCM as their common denominator. Then we can add the rational numbers as in case 1. So we will understand case 2 by taking one example. Like here 1 by 2 plus 1 upon 3. So here we have to add two different fractions whose denominator are different. One is 2 and the another one is 3. So we'll proceed with the steps. First step, we have to take the LCM of 2 and 3, which comes up to 6. Then we have to find out the equivalent fractions for 1 by 2 and 1 upon 3 such that their denominator is 6. So 1 by 2 is multiplied with 3 in the numerator and in the denominator. So we are getting 3 upon 6. And 1 by 3 is multiplied with 2 in the numerator and in the denominator. So we are getting it up like 2 upon 6. Now they can be added. So 3 by 6 plus 2 by 6 comes like 5 upon 6. Then properties of addition of rational numbers. Closure property. According to this property, any two rational numbers, if again they are added, we will get a rational number. Commutative property. Two rational numbers can be added in any order. Like, as in the example you can see, 1 by 2 plus 1 by 3, we have got its answer as 5 upon 6. If you will write down 1 by 3 in the first place and 1 by 2 in the second place, then also we'll get the same answer, 5 upon 6. Associative property. Addition is associative. So A by B plus C by D plus E by F. So if C by D and E by F is added at first and then their sum is added to A by B, we will get the same result when A by B is added to C by D at first and their sum is added to E by F. Then the next is 0 is called the additive identity for a rational number, which means if 0 is added to any rational number, we will get the same rational number. Existence of inverse. For each number A by B, there exists another rational number minus A by B such that their sum is 0. So let us understand this. For 2, the additive inverse will be minus 2. For 4, the additive inverse will be minus 4, such that when they are added, their sum should be equal to 0. So 2 plus minus 2 will be equal to 0. 4 plus minus 4 is again equal to 0. So here we are going have learned two important things. First one is 0 is the additive identity, and the second one is for every rational number there exists a inverse rational number such that their sum is 0. Properties of subtraction of rational numbers. Closure property. The difference of two rational numbers is again a rational number. Commutative property. Subtraction is not commutative. As we have studied it earlier also, that subtraction cannot be commutative. A minus B is not equal to B minus A. Associative property. Subtraction is not associative also. So here we can understand that the properties of subtraction which is followed is only closure property. Subtraction is not commutative, subtraction is not associative. Multiplication of rational numbers. The product of two or more rational numbers is equal to product of their numerators upon product of their denominators. So it's very simple. If you will multiply 1 by 2 and 1 by 3, so product of numerators 1 into 1 and product of denominators 2 into 3. So easily we can get the answer 1 upon 6. Properties of multiplication of rational numbers. The first property that again we are going to discuss here is closure property. And according to this property, if any two rational numbers when multiplied, the product is again a rational number. Commutative. Two rational numbers can be multiplied in any order. As we know, 2 into 3 is same as 3 into 2. So multiplication always follows commutative property. Associative property. Multiplication is also associative. If A by B is multiplied to the product of C by D and E by F, it will give the same result when E by F is multiplied to the product of A by B and 1 is called the multiplicative identity for a rational number, because if 1 is multiplied to any rational number, the product will be the same rational number. Existence of inverse. For each number A by B, there exists another rational number B by A such that their product is 1. So inverse in case of multiplication means the reciprocal of the original rational number. We can understand like this: 2, if it is multiplied with 1 upon 2, the product is 1. 5, when multiplied by 1 by 5, the product is 1. So easily we can understand that for multiplication, the inverse means the reciprocal of the given rational number. Distributive property of multiplication. If A by B, C by D and E by F are any three rational numbers, then A by B into C by D plus E by F is equal to A by B into C by D plus A by B into E upon F. We can understand it simply: A by B into C by D plus E by F. So for the LHS, we have to open the bracket and multiply the term which is outside the bracket with both the terms inside the bracket. Then multiplicative property of 0. The product of any rational number along with 0 is 0. The product of any rational number along with 0 is 0. So A by B into 0 is always equal to 0. Okay. Then the next that we are going to discuss about the rational numbers is the properties of its division. Let A by B and C by D be any two rational numbers. Then we can write it down like this: A by B divided with C by D. So it is equal to A by B will remain as it is, into the division sign gets changed into multiplication sign, and reciprocal of C upon D. So in simple manner we can understand like this, that the fraction which is after the division sign, or the rational number which is just after the division sign, will be done its reciprocal. We have to do its reciprocal in order to get the division of the two rational numbers. The next is closure property. The division of two rational numbers is again a rational number. Commutative. Division is not commutative. Like 1 divided by 2 is not same as 2 divided by 1. Associative property. Division is also not associative. Rational numbers between two rational numbers. There are infinite number of rational numbers between any two rational numbers. Let x and y be any two rational numbers such that x is less than y. Then x plus y upon 2 is a rational number between x and y. That is, x is less than x plus y upon 2 is less than y. Let us understand this method with the help of an example. Example: insert a rational number between 2 and 3. Here x is equal to 2 and y is equal to 3. So new rational number can be added with the formula given above, that is x plus y upon 2. So 2 plus 3 upon 2, we are getting it equal to 5 upon 2. So 5 by 2 is a rational number between 2 and 3. So we can write it down like this: 2 is less than 5 by 2 is less than 3. Thank you all of you. Stay home, stay safe, and keep studying.